Dear students, last time we discussed about solution and its types. Now our today's lecture is regarding concentration terms. How to express the concentration of solute in solutions. So our topic will be concentration terms. First, tell me what is concentration. Concentration is amount of solute dissolved per liter of solution. Don't get confused here, students, that it is per liter of solution, not per liter of solvent. Per liter of solution means solute and solvent together. Their volume should be 1 liter. So there are different ways to express the concentration of solution. So first is mass fraction. That mass fraction is denoted by capital W. Second is volume fraction. So it is denoted by capital V. Third, it is mole fraction. It is denoted by chi. Fourth, it is molarity. It is denoted by capital M. Fifth, it is normality. It is denoted by capital N. Then we have molality. Molality is denoted by small m. And at last we have parts per million. Parts per million. It is denoted by ppm. So these are the concentration terms in the syllabus of class 12th. So first, and we will take all these concentration terms one by one in detail, and we will be doing a few numericals on it. First, we will discuss mass fraction. Mass fraction. As in last lecture I told that there are two components in a solution. One is the solute and another is the solvent. And solvent is A and B is solute. Let this be solvent and B be solute. Mass fraction. It is a ratio of mass of a component of solution. Mass of a component of solution to the total mass of solution. That is mass of component A and mass of component B. Ratio of mass of a component, so WA, that is mass fraction of solvent, is equal to mass of solvent divided by total mass of solution, that is WA plus WB. My dear students, here I have written capital W, that represents mass fraction, and the small w represents the mass of A, mass of B, here WB. It is a dimensionless quantity, that is there are no units for this because it is ratio, and this is temperature independent because mass never changes with temperature. Here we have WB. It is mass of B divided by mass of A plus mass of B. sum of the mass fractions of different components in the solution, that is WA plus WB, it is always equal to 1. Sum of the different ratios is always equal to 1. So this is mass fraction of A and this is mass fraction of B. If we multiply fraction with 100, it becomes percent. So I can also express it in this way: mass percent, it is equal to mass fraction into 100. So mass percent of A is equal to mass fraction of A, that is WA, into 100. So mass percent of B, it is equal to WB into 100. So sum of mass percents of different components in a solution is always equal to 100. So mass percent of A plus mass percent of B is always equal to 100. This can also be expressed like this: mass percent of A, or simply mass percent of A is equal to mass fraction of A. Mass fraction of A, WA, that is WA divided by WA plus WB multiplied by 100. Or simply mass percent of A can also be written like this: in numerator we have mass, in denominator we have mass, and we are calculating the percentage of this mass, so we can write it percentage mass by mass of this component, that is A. Or mass, similarly, mass percent of B is equal to WB divided by WA plus WB into 100. Again, in denominator we have mass, in numerator we have mass, so mass percent of B is equal to percentage mass by mass of B. So if mass percent of A plus mass percent of B is equal to 100, we can write here percentage mass by mass of A, percentage mass by mass of A plus percentage mass by mass of B. It is always equal to 100. So my dear students, I will explain it once again. Mass fraction, it is the ratio of mass of a component of solution to the total mass of solution. So mass fraction of A is equal to mass of that component divided by total mass of the solution. Similarly, WB is equal to WB divided by WA plus WB. So sum of the different fractions is always equal to 1, and we can also write it like this: mass percent in terms of percents. Mass percent is equal to mass fraction into 100. So mass percent of A is equal to WA into 100, or mass percent of B is equal to WB into 100, and mass percent of A plus mass percent of B is equal to 100. So mass percent of A is also equal to WA divided by WA plus WB multiplied by 100. Similarly for this, so percentage mass by mass of A plus percentage mass by mass of B, that is always equal to 100. So this is the mass fraction. Another concentration term is volume fraction. See, if we will replace this capital W with capital V and small w by small v, we can get another concentration term that is known as the volume fraction. So let us discuss volume fraction. Volume fraction. See, my dear students, I will not change much in this. If you learn mass fraction, you need not to learn then volume fraction. You can replace mass by volume and then you will get the volume fraction. So ratio of mass, not here mass, it is ratio of volume of a component of solution, not to the total mass. Here it is total volume of solution. Simple. So it is mass fraction. This volume fraction is denoted by capital V. So if I will replace this capital W by capital V, so it will become volume fraction is equal to volume of A divided by volume of A plus volume of B. So similarly for WB, it is VB here. It is volume of B divided by volume of A plus volume of B. So sum of different ratios is always equal to 1. So I can write here volume fraction of A plus volume fraction of B is equal to 1. So volume percent, similarly volume percent is equal to volume fraction into 100. So volume percent of A is equal to VA into 100. So volume percent of B is equal to volume of B into 100. So mass fraction or mass percent, that is volume percent of A plus volume percent of B is always equal to 100 here. But this has no units, and this volume fraction is temperature dependent. Why? My dear students, as all of you know that volume is the temperature dependent quantity. Volume changes when we change the temperature. So here we can write volume percent of A is equal to volume of A divided by volume of A plus volume of B multiplied by 100. So mass is replaced by volume and capital small w is replaced by small v. So this is volume percent of A is equal to percentage, not mass by mass, but volume by volume of A. Here similarly mass percent of B, that is equal to volume of B. We can replace mass here by volume. So VB divided by VA plus VB. Mass percent of B is replaced by volume percent of B. So percentage volume by volume of B. So mass percent again replaces, this is percentage volume by volume of A plus percentage volume by volume of B is equal to 100. So in this concentration term, nothing is changed here except WA, and this capital W is replaced by capital V and small w is replaced by small v. Once we replace mass by volume, then it becomes the volume fraction here. So this is the term. Another concentration term, this volume fraction. And the most important concentration term that we have, one of the most important concentration terms, that is mole fraction. Very, very important, mole fraction. So mole fraction is denoted by chi. So what is mole fraction? Mole fraction, it is denoted by chi. It is a ratio of moles of a component of solution, of a solution, to the total moles of solution. So now mass and volume is replaced by chi. Let this be chi A. So mole fraction of A is equal to number of moles of A divided by number of moles of A plus number of moles of B. That is ratio of moles of this A divided by total moles of the solution. So it is a dimensionless quantity, that is no units because it is ratio. And this is temperature independent because by changing temperature, number of moles never change. So chi B is equal to NB divided by Na plus Nb. So chi B is equal to Nb divided by Na plus Nb, and this sum of different fractions, just I told you that chi A plus chi B will always be equal to 1. So if one fraction of moles is calculated, then another can easily be calculated. Chi A is equal to 1 minus chi B, or chi B is equal to 1 minus chi A. Mole percent. is equal to chi into 100. That is mole fraction of that component multiplied by 100. So mole percent of A is equal to chi A into 100. Mole percent of B is equal to chi B into 100. Sum of the different fractions is equal, sum of the different percents is equal to 100. So mole percent of A is plus mole percent of B is equal to 100. Mole percent of A plus mole percent of B is equal to 100. Or similarly, percentage mole by mole of A plus percentage mole by mole of B, percentage mole by mole of A plus percentage mole by mole of B is equal to 100. My dear students, you will note down a question, and next time we will discuss that question. That is a simple question, that a solution, question is, a solution has been prepared. Everybody will note that a solution has been prepared by dissolving 20 grams of ethanol, 30 grams of acetic acid in 50 grams of water. Find mole fraction and mass fraction of each component. So this question will cover the two concentration terms, that is mass fraction and mole fraction. So this you will take as homework. So this is mass fraction and mole fraction. Now another most important term of this concentration, that is molarity, which is often used in chemistry, that is the molarity. During practicals, this term is used most of the times. Molarity. This molarity is denoted by capital M. Molarity is denoted by capital M. It is number of moles of solution, number of moles of solute, dissolved per liter or per 1000 ml of solution. So it is per 1000 ml or per liter of solution, per 1000 ml or per liter of solution. That means it is volume dependent. It depends upon volume. By changing the temperature, volume can get changed. So this is temperature dependent. That's why when we prepare the molar solution, it should be used as and when it is prepared, and after that it should be thrown out, because by changing temperature or when temperature changes, its molarity will definitely change, because it depends upon the volume. So molarity, it is equal to number of moles of solute dissolved per liter of solution, that is volume in liters. This is equation number first. So what will be the units? That's moles, liter, that is equal to moles per liter, and this moles per liter will take the cognizance of, this m will take the cognizance of moles per liter. So this is m. So number of moles of solute divided by volume in liters. Similarly, molarity is equal to number of moles of solute divided by volume in milliliters multiplied by 1000. So this is equation number 2. Why multiplied by 1000? Because units should, again, if you will use the milliliter here, even then the units will be in liters, moles per liter. So molarity, as all of you know, this number of moles is always equal to mass divided by molecular mass. Mass in grams divided by molecular mass. So molarity will be equal to number of moles can be replaced by mass of this B, that is solute, divided by molecular mass of B into what? This 1000 divided by this volume in milliliters, and this will be the equation number 3. My dear students, this term, this term, mass of solute into 1000 divided by volume in milliliters is known as strength of the solution. This is known as the strength of the solution. What is strength? It is mass into 1000 divided by volume in milliliters. This is strength, and it is denoted by S, and it is expressed in strength grams per liter. So molarity can also be replaced by, this is strength in grams per liter divided by molecular mass of solute, and this is equation number 4. My dear students, sometimes there is percentage by mass of solute and the density of solution is given. That time, how can you calculate the molarity? Now, if percentage by mass and density of solution, this is rho is known as density, solution is given, then molarity is equal to percentage by mass into density into 10 divided by molecular mass of solute, and this will be the equation number 5. So molarity for dilution. Molarity for dilution. Molarity for dilution. How can you calculate the molarity for a dilution? Suppose you have a solution, its molarity is M1, and you know its volume, it is exactly V1. Now, add some solvent to this. Its volume certainly changes. Now this volume, say it is V2. Then M1 also will change. So molarity also changes. So final molarity, that is M2, that is unknown, so that we have to calculate. So if V1 volume of M1 molar solution, if V1 volume of M1 molar solution is diluted to a new volume of V2, if V1 volume of M1 molar solution, so the volume of this solution was V1, if it is diluted to the new volume of V2, so molarity M1 is the initial molarity, the final molarity, resulting molarity we can calculate with the help of molarity equation. So if V1 volume of M1 molar solution is diluted to a new volume of V2, then the resulting molarity is given by molarity equation. So it is given by molarity equation, that is M1 V1 is equal to M2 V2. So keep this equation number, this is equation number 6. Why this M1 V1 is equal to M2 V2? Here, as you know, molarity is number of moles divided by volume. Number of moles divided by volume. So MV is equal to N. If molarity is M1 and volume is V1, number of moles Bn. Now this molarity is, it changes to M2 and volume changes to V2 with the help of dilution. So the number of moles of solute will always remain same because it's fixed, it will always remain same. So M1 V1 is equal to N, M2 V2 is equal to N. So similarly M1 V1 is equal to M2 V2. So this equation is known as the molarity equation. This is known as molarity equation. Now we have a very important molarity concentration term. Molarity for mixing of two solutions. Molarity for mixing of two solutions containing same solute. Containing same solute. Suppose we have a solution, it is molarity is M1 and volume it is V1. Another solution, its molarity is M2 and its volume is V2. But both have the same solute, say sodium chloride, say sugar, ethanol, acetic acid, any solute can be there. But V1 volume of this solution has molarity of M1 and V2 volume of this solution, it has the molarity M2. So now mix the two solutions. So what? Mixing the two solutions. So that is if V1 volume of M1 molar solution, if V1 volume of M1 molar solution is diluted to a new volume of is mixed, it is mixed with V2 volume of M2 molar solution containing same solute, the resulting molarity M3 can be calculated as M3 is equal to M1 V1 plus M2 V2 divided by V1 plus V2. So if this V1 plus V2 is V3, then M3 V3 is equal to M1 V1 plus M2 V2. So this, both equation, this or this, it's one and the same. So this is equation number 7th. It is equation number 7th. So this is, now we have very important, that is molarity for the chemical reactions. So how can we can use this once we perform the practical in the laboratory. So there you will see a practical, you will come across the practical, that is volumetric analysis, and this molarity for chemical reaction that I am going to discuss, that can be used there. So molarity for a chemical reaction. Molarity for chemical reaction. Dear students, molarity for chemical reaction. Molarity for a chemical reaction. Molarity for chemical reaction. Molarity for chemical reaction. Say N1 times of A is treated with N2 times of B, it results in the formation of products. So this results in the formation of products. So molarity will be M1 V1 divided by N1. This is the stoichiometric coefficient of A, stoichiometric coefficient. stoichiometric coefficient, that is number of moles, and will be equal to M2V2, that is the molarity and volume of B, divided by N2. So product of molarity and volumes of a concentration term is divided by its stoichiometric. So M1V1 divided by N1 is equal to M2V2 divided by N2. Why? Because sometimes number of moles of A are required to number of moles of A, that is N1, are required with this are required to neutralize or react with number of moles of this B, that is N2. So if N1 and N2 are equal, then we need not to divide these product of molarity and volume of a concentration term by its stoichiometric coefficient. N1, N2. So this N1 is not equal to N2. So then if molarity of A and volume of A is given and volume of B is given, and stoichiometric coefficient can be seen through the chemical reaction, then molarity of M2 can very easily be calculated. So this is the molarity for the chemical reaction. So M1V1 divided by N1 is equal to M2V2 divided by N2. So this is the model. Now I will give some questions that you will do at your home. So that is homework, I can say. Now a few questions I can write on the whiteboard. So you will note all these questions, and then we will move to the next concentration term. For example, solution. This is number 1 question. (0.212 grams of sodium carbonate have been dissolved. 0.212 grams of sodium carbonate have been dissolved in 200 ml of solution. Find its molarity. So this is question number 1. Then question number 2. A solution of HNO3 has strength of 6.3 grams per liter. Find its molarity. Find its molarity. So question number 2. Then we have question number 3. A solution of H2SO4 is 98% by mass, and its density is 1.4 grams per cc. Find its molarity. 4th, 100 ml of 0.25 m, that is molar solution of HCl, are treated with or diluted to a new volume of 200 ml. Find the molarity. Find the molarity of resulting solution. Find the molarity of resulting solution. Now, next question, 5th. I will give the 6 questions. 200 ml of 0.5 m solution of sugar is mixed with 500 ml of 500 ml of another sugar solution of molarity 0.25 m, find molarity of resulting solution. Find molarity of resulting solution. Then last question I will give you, that is 100 ml of 0.25 m NaOH is neutralized by 50 ml of HCl. 50 ml of HCl. 50 ml of H2SO4. Find molarity of H2SO4. So these are the 6 questions. You will take it as homework, and next time we will discuss these questions, and so that you will do practice on these concentration terms for mass fraction and for mass fraction and mole fraction. Already a question is given as homework. So these are the 6 questions, the good questions, simple and very conceptual questions, and such type of questions are asked in the entrance examinations for JK, CET, etc. So do these, and this was all for the day for this lecture.